we are going to start. So it says some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is this true? Are the abilities somehow related? Okay, so we're going to collect data from our class on whether or not we can fold our tongue into a taco or whether or not we can give the evil eyebrow. Okay, so what we are going to do is we are going to, I'm going to ask each category, okay? You are only going to raise your hand one time, okay? And when you raise it real high so I can count. And don't put it down until I tell you to. That's okay. So raise your hand if you can make your tongue into a taco and the evil eyebrow.
Wow.
I lost count. That made me lose count. That was your fault. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Jordan, that was entirely your fault. Entirely your fault. All right. Now, can you just turn your tongue into a taco, but no evil eyebrow? 1, 2, 3, 4. Okay, so how many people in total can make their tongue into a taco?
8.
All right, how many people can make that evil eyebrow but cannot turn their tongue into a taco?
Good question.
Anyone?
Oh, wait, what'd you ask?
Okay, how many people can do the evil eyebrow but can't turn their tongue into a taco?
That's a tongue twister.
Oh, okay, Lily.
Okay, now, how many people can't do either?
It's 2.
2?
It's me.
Oh. How many people can't do either?
Wow.
All right, so how many people just can't do a taco tongue?
3.
So how many people in total do we have?
21.
Why are there, is there not 22 people in here?
Someone's not. Kelly's missing. Kelly's not here. We're lying again.
Oh.
Alright, guys, mess up.
Yeah,
I
but
counted.
there's 21?
Yes.
Oh, I counted 22. Like, I wasn't going off of roll. I was like,
22. I think.
Why are you holding your ear?
There's 22.
there's 22. Who didn't vote?
I'm rotating this thing.
Mike didn't vote. Bro, who's not voting? Like, you can't keep getting away with it. We had the same problem last time.
We did have the same problem last time. No, Peyton. Peyton, you voted, right? Janiyah, did you vote? Who didn't? You voted, but I'm still convinced you lied. Because do the taco tongue again. Oh, okay. The last time I saw you do it, it didn't look right. And I was like,
It's had to do with the little flower something too.
Oh, okay. Okay, and now this is frozen. Why? Y'all. Yes, you can go to the restroom. All right, okay. Now that we're done. So, how many people can do the evil eyebrow?
Yeah, I'm gonna like 6.
Okay. How many people can't do the evil eyebrow? So, for a total of how many people? All right, let's stop our extra conversations, all right? So, now we're going to make that into a Venn diagram. Okay, so in a Venn diagram, we have one part that we put for one event, one part for the other, and one part for both, right? So, what goes right here in the middle? Both. So, how many people can taco tongue and evil eyebrow?
14.
How many people can just taco tongue?
4.
How many people can just evil eyebrow?
2.
How many people can do neither?
1.
Okay. So that is our full sample space. All right, now we are going to find some probabilities. So suppose that we randomly choose a student from class. Find the following probabilities. Okay? The probability that, yes, they can taco tongue. How many people in total can make a taco tongue?
14 out of 21.
So 14 out of 21. Okay, can I simplify that at all?
2 out of 3. 2 out of 3.
Oh, yeah, 7 goes into both.
I know.
I was forgetting that 7 existed.
It's okay.
All right, probability of yes, evil eyebrow.
14 out of 21.
How many people can do the evil eyebrow?
14.
No, wrong one.
Oh, y'all told me a lie. How many people can taco tongue again?
Oh, 18.
18. Okay, so that changes our simplification to what? 6 out of 7, right?
But what? How?
You can take out a 3. 18 divided by 3 is 6. 21 divided by 3 is 7. All right.
If only it was even right.
Now, okay, yes, evil eyebrow. How many people can raise just their evil eyebrow? 16 out of 21. What can go into both of those? Nothing, right?
Really? Really?
Because, yes. Why are you confused?
Mine just started in the first one.
Oh, never mind.
Stop. Are you no longer confused?
Yes.
Okay. Now, what about the probability of no taco tongue?
It was 3 over 21.
Okay. What is the simplification of that? 1/7. Okay. Probability of no evil eyebrow. 5 out of?
21.
Can we simplify that? No. All right, now. Probability of yes, taco tongue, and yes, evil eyebrow. So how many people can both taco tongue and evil eyebrow?
14 out of 7. 21.
14 out of 21. Okay,
It's just 2/3.
which is 2/3. Okay, now, what about probability of yes, evil eyebrow, and no taco tongue?
2 out of 21.
Can we simplify that?
No.
All right. What about yes, taco tongue, and no evil eyebrow?
4 out of 21.
Can we simplify that?
No.
No taco tongue and no evil eyebrow.
1 out of 21.
I swear, with no context, it sounds like I'm saying something crazy. All right. All right. Now, okay, we are going to look at number 3. So number 3 has us randomly choose a student from the class and find the following probabilities. So probability of yes, evil eyebrow. What is that? 16 out of 21. I'm just confirming. I no longer trust y'all. Okay, what is the probability of no evil eyebrows? Now, are these two events mutually exclusive?
Yes.
Yes. Okay. So, what makes two things mutually exclusive?
They can't have the same thing at once.
You can't have the same thing happen at the same have it happen at the same time. Okay? So, those two things are mutually exclusive because your eyebrow can either be evil or not. Okay? That's it. So, whenever we have mutually exclusive events and they're ors, what do we need to do with them to find the or probabilities? Add them together. So, we're just going to do 16 out of 21 plus 5 out of 21. What is 16 out of 21 plus 5 out of 21? 21 out of 21. What does 21 out of 21 simplify to?
1.
So, what's happening there is how many people in here can raise their evil eyebrow? Raise your hand. Okay, now keep y'all's hands raised. How many people cannot have an evil eyebrow? Raise your hand.
Keep your hand raised.
Yep. So, everyone should have their hand up right now, right? Because it can be either. That's why it's a probability of 1, because everybody in here can do one or the other. Okay? Now, you can put your hands down now. Yes. Micah, stop being annoying. Pick up a pencil. You don't even have a pencil out.
Bro.
All right. Suppose that we randomly choose a student from the class. Okay. Suppose that we randomly choose a student from class, find the following probabilities. Probability of yes, taco tongue. What is that?
18.
18 out of 21. Or 6/7, yes. We are just going to leave it as 18 out of 21 for this, though. Okay, what about the probability of evil eyebrow? Okay, are those two things mutually exclusive? No. Okay, because some people can do both, right? So what we have to do in order to find a or probability when they are not mutually exclusive, it's a little bit different. Okay? So if we look at these, okay, if I was to just add them together, okay, what would the probability be if I just added those together? It's over 1. Can we have a probability over 1? No. Okay, so let's look at something real quick. So if I go up here, so it's wanting us to take the probability of yes of having a taco tongue and yes having an evil eyebrow. Okay, so it's wanting us to count up all of those things. How many times is this value right here getting counted? Twice. So what we have to do whenever there's any overlap is we have to subtract out the overlap. Okay, because it's getting counted twice, so we're going to subtract that overlap so that it's only counted 1 time. Okay, so what we're going to do is we're going to do 18 over 21 plus 16 over 21. And then then we're going to subtract the both of them. What was it? 14 over 21. So whenever I add 3 things with the same denominator, does the denominator change?
No.
So what is 18 plus 16 minus 14?
20.
So 20 out of 21 people can either do the taco tongue or the evil eye. Okay? And that makes sense because how many people said they could do neither? 1. Okay? And so now we're going to go ahead and look at the back and we're going to kind of formalize that rule. Okay? So all of the or probabilities we've done up to this point have been with mutually exclusive events. Okay? This is what we do when they are not mutually exclusive events. Okay? So we have the general addition rule, which says if you have the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay? So remember, union is or, intersection is and. If you would rather write it as the probability of A or B in the intersection of A and B, you can do that. Just make sure you know the meaning of both because they can be given to you either way. If it's given to you in a way you don't prefer, you can rewrite it the other way. There's not a big deal about that, but you need to be able to recognize what it means. Okay, so we're going to do an example. Okay, so we're going to look at the relationships between educational achievements and home ownership. Okay, a random sample of 500 U.S. adults were selected. Okay, a random sample of 500 U.S. adults were selected. Each member of the sample was identified as either a high school graduate or not, and as a homeowner or not. And then the two-way table displays the data. Okay, so first, let's finish out this two-way table and get all of our totals. How many people in total are homeowners? Nope.
It just turned off.
I can't go.
It's 340.
340. Yes, 340. Whoa. Oh, I get it now.
I was just getting my notes so I could confirm things. First period today, we misadded everything, and then I got really, really confused, and my brain stopped working for like a good 15 minutes. All right, so what is the total for that again? 340. Okay, what is the total for no home ownership? 160. And then how many people were surveyed? 500. Okay, now how many people graduated high school out of the survey?
A lot. 310.
How many people did not And does that still add up to 500?
Yes.
Okay, well then we're good. All right, so now we are going to, suppose we choose a member of the sample and we're going to define G as a high school graduate. Okay, so where it is yes, that is going to be our G. That is yes, a high school graduate. Where it is not a high school graduate, we're going to do G complement, which just means not G. Okay, it's G and not G. Okay, then for homeowners, okay, we are going to name that event H or H complement, which again just means not H. Okay, and then we're going to look at our probabilities we have here. Okay, so for the first one, we have the probability of G complement. So the probability that they are not a high school graduate. How many people are not a high school graduate? 190 in total, right? So 190 out of how many? 500. And can we simplify that?
19 out of 50.
Okay. And this is one where I would also be okay if you wrote it as a fraction. So what would that be as a fraction? Or not as a fraction, as a decimal. My bad. 0.38. Okay. Now, we are going to look at question 7. So it asks us why we can't find the probability of G or H by just adding them together. What relationship do G and H have that makes it where you can't just add them together? They are not mutually exclusive, okay? So G and H are not mutually exclusive. Okay, now we're going to actually find P of G or H. So one thing I do almost every time I have one of these problems is I just set it up according to the rule with the letters. So like I just rewrite the rule using whatever events I have in the problem. So right now I have G or H. So I'm going to do the probability of G plus the probability of H. And then we need to subtract the probability of G and H. Okay? That's the first thing I do when I have one of these, just because this makes me less likely to make a mistake on what I pick when I go to write out my things, like what the actual probabilities are. And also, if you was to mess up and accidentally write the wrong probability right here, but you wrote this, I know you know what you're talking about. So like I can give you half of your credit. Does that make sense? Okay. Take your ear tumors out, please. Yep. Thank you. Okay. Now, probability of G. What is the probability of G?
310.
310 out of what?
500.
What's the probability of H?
340 out of 20.
Now, what is the probability of G and H?
221.
Okay. So we will get what out of 500? What is 310 plus 340 minus 221?
429.
429. Okay. Can we simplify that? No. So that is our probability. We could also write that as a decimal, though. What would be the decimal equivalent of that?
86%.
Okay, there we go. So there's an 86% chance of them either being a high school graduate or a homeowner. Okay, now we're going to make this into a Venn diagram. Okay, so we're going to draw our square, or not a square, a rectangle. I know, I'm going to answer it. Draw your in your circle. Ah!
Hello, this is Miss Williams. I'm I'm good. How are you? No, she's not in here today. No, ma'am. Thank you. All right. So we are going to put in here 2 circles where they overlap. I'm so sorry. It's as cold as my heart. All right, and give you a place. I said that yesterday to someone, and they laughed at. I did? No, I said it to someone else yesterday, too, when I was literally dressed in head to toe yellow yesterday. And somebody went,
Your favorite color is yellow. It's not that dark. Cold.
it's fine.
Just quit later.
I mean, it's just that the cold never bothered me anyway.
Oh my gosh, Elsa. No, you're giving Anna. You're giving Anna. I can't even lie.
Close that back door. You might get snitched out by your home.
All right, so what needs to go in the overlap section?
Both.
So how would I put that? 221. Okay, we let one side be homeowners, one side be graduates. How many people are homeowners but not graduates?
340.
190.
How many people are graduates but not homeowners? How many people are neither? Okay, so what happens whenever we subtract where they overlap? It lets us just find the region inside both circles. Whereas if you just add them together, you're gonna overlap the middle, okay? So we have to go back in and subtract both so that we have just one flat layer all over all of it, okay? Now, we're going to go ahead and look at number 9, okay? Number 9 is the probability is not a high school graduate and is a homeowner, okay? So the probability of G complement and a homeowner. How many people are not graduates and homeowners?
190.
So it'll be 119 out of, and let's write that as a decimal just for funsies. 0. There we go. All right, now we are going to look at something called conditional probability. Okay. So let's first talk about why conditional probability is something that's important. Okay. So there are some conditions that change probabilities. So let's talk about a couple random examples. So if I ask you right now, and I said, what's the probability my shoes are wet?
50-50.
Pretty low, but just in if in general, if we went through all of the days of school, my feet aren't wet at school very often, right? Okay, now listen. What happens to that probability when I say, what is the probability my shoes are wet, given that it's raining outside? It's a little bit more, right? So having some condition changes what the probability means sometimes. So if I ask the question, what's the probability I'm wearing a jacket in Mobile, Alabama?
Right now, it's a lot.
Well, just in general.
Oh, not a lot.
25.
It's probably pretty low because it was literally almost 80 degrees on Christmas, y'all. You don't need a jacket half the time. Okay, but anyways, but what if I say, what's the probability I need a jacket in Mobile in January?
A lot.
It makes it higher, right? So by adding in some conditions, you can entirely change a probability, okay? So we're going to talk about how to find that, okay? So the probability, the probability of A given B, that is how you read this right here, okay? That is read as the probability of A given B. And it is the probability of event A given that B has already occurred. Okay? So it's saying the probability my shoes are wet given that it's raining outside. So when I walked from the car in here, my shoes got wet. Okay? Now, we're going to go ahead and write this. This vertical line right here, we read that as given. Okay? A given B. We're saying that A given that B has happened. And the rule for this is that we take the probability that both A and B has happened and divide it by whatever the probability is of our given. Okay? So instead of putting it out of the total, it goes out of what the given is, because it only matters if the given has happened. Okay? So now, we can rewrite that. We can use or in there instead of our, or and in there instead of our intersection. The probability of A and B divided by the probability of B. Okay? So this is like the rule. And then over here, this is just what it means. It's the probability that both happen divided by probability of the given happening. That is what is happening in any of a conditional probability. Take the probability of both, divide it by the probability of the given. Okay? I am not giving you these formulas for the test.
You're not? We have to know.
Oh my goodness.
Okay? So I want you to make sure you know your formulas. Really, the only formulas we have is the addition and the general addition and this one. But, all right. Now, we are going to fill in another table. Okay? So, what is the probability that a randomly selected person from class uses TikTok? What about uses Instagram, uses both, or uses none? Okay? I do not care if you have the app. I only care if you actively use the app.
I use it every day.
Okay? So if you have it but you don't use it, don't raise your hand. Does that sound good? That'll make the data a little bit better. Who uses TikTok and Instagram? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right? Who uses just TikTok? For a total of how many people?
19.
Okay. Who uses just Instagram? 2 people. Who uses neither? Okay, for a total of how many people for no TikTok? Okay, now how many people in total are there? 22. Everybody voted this time. All right, how many people use Instagram? How many people have no Instagram? Okay, so that is our table. Okay, now, thank you. So we're going to do half of these together, and I'm going to leave you the last half to, or the other half to do. So what is the probability of someone using TikTok?
19 out of 22.
19.
Out of 22. I agree. All right. What's the probability of someone not using TikTok?
3 out of 3.
Okay. Now we have the probability of TikTok and Instagram.
15.
Okay. The probability of Instagram or no TikTok. Okay. So is having Instagram and no TikTok mutually exclusive?
Yeah.
No, because you can have an Instagram and have no TikTok. That's fine. So we have to do our general additional, right? So we're going to do the probability of Instagram.
Wouldn't it be just 17?
No, because it's Instagram and no TikTok.
17.
Okay? It's the or probability. Remember, or we have to do the rule. So probability of Instagram
plus the probability of no TikTok minus the probability of both Instagram and no TikTok. Okay? Or probabilities, we have to use one of our addition rules. Okay? If they're mutually exclusive, you just add them together. But if they're not mutually exclusive, we have to subtract at the end. Okay? So what's the probability of using Instagram?
17.
Yep, 17 out of 22. What's the probability of not using TikTok? 3 out of 22. Okay? What's the probability of having an Instagram and not using TikTok? 2 out of 22. So, what is 17 plus 3 minus 2? 18 out of 22. And we can simplify that to what?
9 out of 11.
Yeah. Because we can take 2 out of each. Okay, now, we are going to go ahead and look at a couple given ones. Okay, so we're going to look at the probability of P, the probability of TikTok given Instagram. Okay, so probability of TikTok given they use Instagram. So we're going to do the probability of TikTok and Instagram divided by the probability of Instagram. Because remember the probability of our given. So what is the overlap between TikTok and Instagram?
15.
So we would do 15 over 22 divided by, what is the probability of just Instagram? 17 out of 22. Okay. How do we divide fractions? Keep. So we have 15 over 22 times, what's the reciprocal of 17 over 22? 22 over 17. What happens with those two 22s? And so we just get 15 over 17. That is our probability of having a TikTok given they have Instagram. Which makes sense because up here, 15 of the people that have Instagram, or 15 of the people that have both out of this, never mind. You don't always have that. Okay, you don't always have the big full table, which is why I'm making sure we know how to set up every single thing. Does that make sense? Like I want us to know how to do all the pieces so that if we ever have to do it without having the pieces, we can. Now, we're also going to do K together. Okay, so for this one, what is my given in this? So it's given what? No Instagram. So we're going to have the probability of TikTok and no Instagram divided by the probability of no Instagram. So what is the overlap between having TikTok and not having Instagram? So it'd be 4 out of 22. Okay, so that is this part right here. We're going to divide that by, what is the probability of having no Instagram? 5 out of 22. Okay, so we know that our 22s will end up canceling out, right? So that leaves us with just what? 4 over 5. Okay, so what you are going to do is you are going to finish the last 6 of these questions on your own. Okay, I want you to make sure you can set them up. Yes. Yes. And once you finish those, we're done for today.